All right, moving on to the last part of the lesson. We have simplifying quotients. Now, anytime that you have trinomials as a fraction here, up here we have our a squared minus a minus 6 is the numerator as a trinomial, and the a squared plus 7a plus 10 is the denominator of our fraction. Again, one of the first things to do would be to check if we can take a greatest common factor of everything. It looks like none of our terms in either case are numerator or in our denominator. Doesn't look like we can take a greatest common factor of any of them. But we do want to be looking at them individually, just our numerator on top and the denominator on the bottom. When we look at our top, we have the a squared minus a minus 6. Now, if we wanted to use the AC method, we could, or we could use what we had been working with in Algebra 1. We're going to do the AC method just because we want a little more practice on that. So in this case, a is 1, b is negative 1, and c is negative 6. So AC is 1 times negative 6. AC is negative 6. Again, because our AC is negative, we're looking for two factors, one being positive, one being negative. So we could have either 1 and 6, or we could have 2 and 3. And we need them to add up to negative 1, because that is our b right here, is the negative 1. So if we use 1 and 6, one being positive, one being negative, negative 1 and positive 6 would give positive 5, and positive 6 and, or should I say positive 1 and negative 6 would give a negative 5. Neither of those work for what we're looking for. If we have negative 2 and positive 3, that would give us a positive 1. And if we have positive 2 and negative 3, that gives us a negative 1, which was what we're looking for. So in the end, we know that we need to use 2 and negative 3. So again, we're looking at this time it's going to be a terms. And our a terms come from our a value, in this case, which was 1. And then we look at our constants from our binomial factors. The constants, again, come from our factors of AC. So we have 2 and negative 3. And we need those to multiply and add up to c, which in this case is negative 6. The only two factors of 1 are going to be 1 and 1. So it's not going to be too terribly hard to match those up. 2, we'll just match it with either one of them. 2 divided by 1 is just 2. And negative 3 matched up with the other one. Negative 3 divided by 1 is still negative 3. And 2 times negative 3 is the negative 6 that we were looking for. So we know that in this case, when we make our binomial factors, each one is going to have a 1a as the term. One of our 1a's needs to be paired with a 2, and one of them needs to be paired with a negative 3. So in this case, here are our two binomial factors. And what we can do with that, let's just group them all together. So now that we have our factors of the top one, our numerator, we can set those aside, and we've just grouped only the numerator. That's the first place to start. Now, we'll start all over. We'll use our AC method again, but this time on the denominator, in which case we have, oops, I want a black one, A, B, and C. A in this case is 1, B is 7, and C is 10. So again, we'll go through our AC method like we've done before. A times C is 1 and 10 gives us 10. And since it's positive, either both are positive or both are negative. So we have the factors of 10, which are going to be 1 and 10, or 2 and 5. And again, in this case, what we want them to add up to is B, which is positive 7. And since we know that our B is positive, and both of our factors need to be the same thing, either positive or negative, we know that we need them both to be positive. So if we use both positive 1 and 10, that adds up to 11. That's not what we're looking for. If we use both positive 2 and 5, 2 plus 5 is 7. So that is what we're looking for. Those are the ones we want. So again, we make the columns with our A terms. And we're using our A from over here is 1. Our constants from our binomial factors. The constants that we're looking at, or the factors from AC, are 2 and 5. And we need those to multiply and add up to C, which was 10. Again, the factors of 1 are just 1 and 1. So when we match those up, doesn't matter which one we match it with, 2 and 1 divide to just 2. 5 divided by 1, again, is just a 5. 2 times 5 is 10, which was exactly what we were looking for. So again, we have our binomial factors. We have two A factors. Both of them are just 1A. One of the 1A's needs to get matched up with a 2, and one needs to get matched up with a positive 5. So again, in this case, we have our binomial factor that we found. We can keep that as our denominator. And we'll get rid of the rest of this. So now we've changed our original polynomial fraction into a polynomial with factored fractions. So the top factored out to a minus 3 and a plus 2. And the bottom factored out to a plus 5 and a plus 2. In each of these cases, we can recognize that there is an a plus 2 and an a plus 2. Now, again, if we had a fraction where we had like 3y and 3x, we would notice that, hey, both of these have a 3, so we can just divide that out, get rid of the 3's, and we just have y over x. Well, similarly, if these have the same factors, we can just divide them out, get rid of the a plus 2, in which case, in the end, we're left with an a minus 3 as our numerator, and our denominator is that a plus 5. And that would be how to factor out the quotient of two trinomials.